Students, so in last session we have started a new topic, that is services within the modular networks, right? So we have discussed among the what are the SONA framework architecture, what we have covered, right, which having some in a layered uh, infrastructure or layered framework, right, and within that layer we have discussed in interactive service layer, which having our infrastructure service, different services, as well as some networking services, which is nothing but the top of that particular infrastructure layer services, right? So we have discussed all these things. And then what are the different security services in modular network, because the security, as we know, as a very crucial with respect to any kind of the network design, right? So what are the different services are there with respect to this particular networking design we have discussed, right? And after that also we have seen these there are a different external threats we can call, for example, IP spoofing, then password attacks, then denial of service attack, then application layer attack, right? And how these kind of the attacks will be related to this particular enterprise edge module, right? That also we have seen in our last session, right? So today in this lecture we will be more focused on this high availability concept, right? And what are the different services of with respect to the high availability in modular network design, right? That is designing root redundancies, designing link redundancies, right? Then different device to device redundancies, port redundancies, and all that things we will be discussing in this high availability, right? Then we will have different services with respect to the modular network design, for example voice services, then wireless services, and application networking services, right? So these are the some other different kind of the services which can be also a part of this particular modular network design, right? So we will see these also in today's session, right? So let's start with today's session, right? Yes. So today we will be discussing with respect to the high availability services, right? So whenever you see in any kind of the enterprise, right, the application which are there, some of the applications are very much critical with respect to the organization, right? And with respect to that critical application, your network services which must be available 24/7 by 365 days to the customers, right? So in this regards, this particular high availability plays a very major role, right? Like the security of your information or of your internet networking devices, right? The information is also a very much important thing which must be in secure, right? And it also must be an available to the authentic users, right? So in this way, for critical applications, this particular high ability, if you see, then the some redundant network, right? If we see in a redundant network design, right, that can be duplicate your network links and devices, right, which will be eliminating the single points, right? Okay, 1 second. Okay, so we have some redundant network designs, right, which will be duplicate in every times all the network links, all the networking devices, right? And why this happen, that will be used for eliminating that all single point of failure, right, which will be available on the any kind of the network, right? And for that purposes we are using all the redundant network designing many times, right? But what is the goal is to every time whenever you are using any duplicate components, right? Because if they failed, right, then it will be also disable your critical applications, right? Because every critical application for every critical applications, that particular servers, that particular networking infrastructure, that must be available, right, 24/7, right? And for that, this particular redundancy is very expensive, right? And for to deploy this kind of the expensive redundancies, right, and maintain it, that particular we can use redundant topologies also, somewhere, right? So redundant topologies, in case in short, we can call it as redundant internetworking devices, right? Redundant links and every time, right? So it will be nothing but your redundant topologies, right? But if you use all these redundancies, right, it will be add more complexity to your particular networking topology, right? If we talked about your with respect to your networking addressing, or with respect to your network routing, right, then it will be very much complex if we add redundancies in each and every phases, right? Therefore this particular level of the redundancies, right, should meet the organization's availability, right? And which will be incorporate the organization requirements as well, right? Because if you use these all critical application, if you use all the internet working devices, right, then whatever the links we are identifying, right, and to analyze this kind of the risk, right, we need to implement the redundancies, right? And also you need to check whether all the devices which we are using in any kind of the network, right, whether it will be fault tolerant or not, right? Whether the redundant links should terminate at different devices or not, right? Because what happen if it is not, then devices which not as a fault tolerance, right, that can be your single point of the failure, right? Then you should avoid these kind of the things, right? And for that purpose, all these redundancies types are over here. If you see, the first is your device redundancies, right? So it will be include your network card as well as your port redundancies, right? So that can be you can use, right? Then redundant physical connections to the critical workstation and the servers, right? Then root redundancies is there, link redundancies is there, right? Then power redundancies is there, right? For example, the main power supply, if any integral power supply is fails, right, then you must have some different alternatives to that, right? So power redundancies is also will be required, right? Which can be a building physical plant, redundant power to the building physical plant and all that things, right? For example, if you see in your apartment where you are living currently, right, there also one backup for your lift is there, right? So that is nothing but the power redundancies to that particular lift, right? So likewise, some redundancy you need to apply to some critical applications, right? Some of the modules of your enterprise, you must add these types of redundancy in order to get the high availability to that particular thing, right? So if you consider the high availability in the server farm, right? The server farm, we have already seen, the server farm is nothing but the collection of different kind of the servers taken together, is just like an your centralized server room in room number 318, right? So if you consider the high availability in that particular server farm, why? Because this particular server farm having some critical applications or critical workstation, right, different kinds of important servers, right? And you need to use that particular thing, which will be always be depends upon the operating systems and hardwares and softwares, right? So you need to check its availability, right? So for that you can be used we can call it as a single attachment, right? If you your workstation, when a workstation or server needs to send traffic, right, which is not local, and which will be also know the address of your router. Why? Because if you see the core in core layer as well, right, whatever the traffic you or whatever the packet you need to send, it will be sent it to your the router first, right? Then if that particular router is failed, right, then what happen, right, your network will be collapsed if your network is not obeying your hierarchical network layer model, right, that is your distribution layer, core layer, and the access layer model, right. So if the router fail, right, the workstation or server whatever you are using, that needs to be check for the alternative router, right. It should be discover any new router, right. And because if the workstation or server has a single attachment, right, then it will be needs a layer 3 mechanism, right, which can be dynamically find these alternative routers, right. Therefore this single attachment method is not recommended any kind of the network designing part, right. So if you see in any kind of the network design, okay, this single attachment is nowhere used, right. Why? Because it is always used it is always need that layer 3 mechanism, right, which will be dynamically find the alternative router, right, and it will be tedious one, right. So then what is available scenarios, right. So we have an ARP, then we have some RDP, some protocols we have, right, which will be do this task for us, right. For example, router discovery protocol, RDP, we can use address resolution protocol, right. So these can be discover the routers, right, for us, and for that we can have, if our router fails, then we have an alternative routers available with us, right. So it can be used in this particular server farm, right. Then if you see the next one is the attachment through redundant transceiver, we can call, right. If you see in this particular diagram also, right, in this critical workstation or server I am telling about, right, which having some device drivers, NIC card, right, and it having some transceiver, right, which will be connected to your one primary switch and one backup switch, right. So physical redundancies with the transceiver attachment, okay, it will be very much used in kind of this particular physical redundancies we can call, right. Then if you see this particular second one, that physical redundancies through NIC card, right. So here I am using the two NIC cards in this particular critical workstation, which will be again responsible, or which will be again useful for attaching to the each primary switch and the backup switch, right. And again primary switch and backup switch are interconnected, right. So this we can use as a primary and a backup NICs, okay. Then we have another one is your fast Ethernet channel or gigabit Ethernet channel. We can use this the port bundles we can use, right. For example, if you wanted to group multiple Ethernet ports, right, then at that point you can use these port bundles in order to transfer the traffic from one to another one, right. So this can be a useful one, right. So in order to installation of additional NIC or additional interface card, the server can provide the redundancies, right. And in this part the redundant by using redundant transceiver also, which having a two uplinks, right, which will be connected to the switches, right. And then the transceiver can activate the backup port, right, after it detects a link failure. For example, this particular primary switch link is failed, right, then the transceiver can activate this particular backup switch port, right, and then it will be used in this particular backup switch always, right, whenever it detects the failure, right. So this can be a redundancies of this transceiver, right, and this can be redundancies with respect to your NICs, right? So we also following these particular practices in our 318, right? So we have an whatever the server we have, right, we are using this particular multiple NICs over there, right, in order to provide the redundancies to our servers, right? So that also you need to check upon, right? Then we have how we are going to design the root redundancies, right? So the two main purposes of root redundancies is what. The first one is what, to whatever the whichever the link is failed, right, so that we need to minimize it effect, right? That is the first one. And how you are going to minimize this by giving the root redundancies, right? And the second purpose for this redundancies of root is what, it can be minimize the effect of the internet networking device failure, right? For example, if you see in this particular diagram, right, if this particular switch is failed, right, then we have this particular switch as a backup switch. So now what you need to do is you need to convert or divert all the traffic towards this particular switch, right? So in a short way, for example, if one road is a block, right, then you need to find out the other road or other way to reach your destination, right? So in this case also, if one device is failed, then that redundant route you need to be used, right? And this can be used many times as a load balancing, right? And when it will be used for the load balancing, when all the roads are on or are available, or all the switches are up, right, at that time you can use this particular load balancing as well, right? For example, some traffic you can move towards this particular road, some traffic you can move forward to this particular road, right, that way. Okay, so this can be used as a we can call it as root redundancies, right? And how you are going to achieve this, right? You can use this for by using this parallel physical links to between the switches and router you can use, right? You can use in a backup LAN, or you can use it as backup WAN as well, right? And how you are going to use this, and there are two ways, right? For example, if you see this particular architecture is nothing but the completely mesh type topology is there, right? So this particular mesh is provide you the complete redundancies, right? And it will be also gives you an good performance, right? But if you are using the partial mesh, right, which will be also useful, right, which will be also a scalable one, right? That can be also one way to represent your network, right? So that can be also a part. Then we if we see the if the distribution switch fails, right, this particular difference distribution layer switches fail, then access layer switch can be still communicate with the distribution layer with the help of this particular switch that I have already told, right? And this particular multi-layer switches can be used as a one as a primary and another one as a backup one, right? So that we can call it as a backup path also in between the access layer and the distribution layer, right? And it will be depending upon your the links updation, right? When whichever link is up at the time of your sending any kind of the traffic, so it can be detected, right? So by using different algorithms, right? So which algorithms, routing protocol, by using any kind routing protocol also, you are going to transfer the packet from one switch to another switch, right? Because these are nothing but your the dynamic routing protocols, right? So it will be check the best path, right? It will be check the best route for you, right? And according to that it will be transfer the traffic to these particular routes, right? So these particular routing protocols is also very much plays an important role while designing the route redundancies part, right? So I hope you understood this particular concept. Then we will have this particular link redundancies point, right? So whenever if you see in a link redundancies, right, if you see in this particular example also, this is nothing but your enterprise edge link redundancies. Okay, so in this here, if you see, the frame relay circuit is used, right, which will be in parallel with this particular IPsec, hmm, over the internet, right. So the backup line can be used in a different technology, right, but it will be important that the backup that will be provide the sufficient capacity, right, to meet the critical requirement of this particular whenever the primary route fails, right. So all these things must be very much important with respect to this thing. Okay, because this particular backup links which will be always be on, right, whether because whenever the primary link goes down, right, so, or it will be congested, right. So if any congestion is there in network, right, then also that particular backup link can be used, right. So it will be helpful in this particular link redundancy designing, right. So this is a very much important point. Then we will have some voice services, right, in this particular modular network designing, right. If you consider any VoIP, that is voice enabled over voice over internet protocol, right, IPs, right, then it will be use some voice enabled routers, right, over here in order to convert the analog signal into your we can call it as IP packets, right. And in this particular IP packets can be we can call convert into digital voice channels, right. And this particular which having its corresponding locations, right. So whenever wherever they wanted to send, right, we can send by using VoIP, right. And another way is for transferring packet is nothing but your the IP phones, or if you can call it as an IP telephony, right. So by using IP phones also, that particular server we can we can control and call these particular signals, right. For example, if we consider this Cisco Unified Communication Manager, this particular devices also, right, it will be also useful for your IP telephony, right, because it will be perform your voice to IP conversation, right, and vice versa, right. So it will be also used for your PSTN application, right. So all these things we are going to use in our IP telephony, right. So these are the some components. Okay, so Cisco Unified Communication Manager, which will be used for conversion between voice to IP, right. In this particular IP telephony, then this particular VoIP routers, or we can call it gateways there, right. We can also call it as an PSTN gateway, right, because it having if you connect PSTN connection is required for your voice enabled router, right. And then it will be moved towards your the enterprise edge, right. And from that you will also connect the third party application like voice messaging, or any voice mail applications you can connect with this particular enterprise edge network, right. So this also can be a part, right. If you see in this particular IP phones, or in particular this particular kind of the switches, right. So each of the switch is having some PoE, right. So power of inline power we can call it as, right. And with the help of this centralized power to all these routers in this unified manager, then this IP phones, then this particular external applications, right. We can have the some of the LAN ports to these particular IP phones which are connected, right. And then the switches also perform some basic QoS tasks, right. For example, any packet classification it can be done, then any prioritize voice, for example, in a network, right. Then also it can be possible by using this particular switches, right. So this kind of the thing are there with respect to your IP telephony, right. And if you see the different we can call it voice network, right. Or we can now shift it to your wireless services, right. So if you see in wireless services, okay, one second. Yes, in a wireless services, if we talk about in a modular network, right? So we have certain four components we have, right? The first, for example, the WAC is nothing but the wireless LAN controller, right? So these WAN controllers can be managed and support these wireless services, right? For example, if we know the concept of roaming, right? So this kind of the services it can be performed by this particular wireless LAN controller, and which will be available in the core layer of your enterprise network. Okay, just remember that it will be available in your core layer, okay, not in the distribution layer, right? Then in this particular existing switch and routing wired network, it having your the APS, right? That is nothing but the access points, right, for this particular wired network. And then this particular will be connected to your the endpoints, so that is nothing but your the end user devices. Okay, so this particular PC or end user devices which will be considered in your the access layer users, right, and it will be connected to your the wireless NIC, right, by using which this particular wireless AP, that is access points, right, by using this particular radio wave, the radio wave you are seeing here, right. So by using this radio waves you can connect with this particular wireless access points, right, and this wireless access point who is controlling this particular wireless LAN controller, right, and which is available in your the core layer part, right. So that also you need to keep in mind. So all these four components are there for your the wireless LAN, we can call it as wireless LAN components. Okay, so this is important one, and last one is nothing but your the application networking, we can call it as an environment, right, application networking services in the modular network, right. So if you see in this particular WAN architecture, right, so whenever we have talked about the last remote access model in enterprise network design, right. So in that also we have seen these particular regional offices there, then some have branch offices, remote offices, some have data centers and all that things, right, and all these things are interconnected, right, to your central office, that is nothing but your the regional office, right, and remote office is connected to that, branch office is connected to that, data centers, so all these part is connected to your one data center, right, and this is nothing but your the, we can call it as a wide area network, right, that is nothing but your the WAN. Okay, so where all these kind of the offices which having some infrastructure, right, also having some third party applications, right, which will be which can be a connect together to from any kind of the branch office, regional office, or from the remote office, right, provided the security services whatever we have studied, right, that can be also a part of this particular application networking services, right. So this also very much important with respect to the WAN. So we have talked about the LAN as well as we are now seeing this particular WAN, how this particular infrastructure look like. So this is all about today. So we have seen today the with concepts with respect to your high availability services in a modular network design, right, in terms of the root redundancy, in terms of the link redundancies, in terms of the device redundancies, in terms of that NICs redundancies, port redundancies, right, all these things we have seen which will be responsible for your high availability services in your modular networks, right. Then we have also seen the voice services in modular network, VoIP, right, the IP telephony components we have seen. Then wireless services we have seen in a modular network, and last one we have seen this WAN, that is wide area network. What are the different application networking it have, and in different branches, and how it will be connected to your regional offices, right, that also we have seen, right. So this is all about today. So we have covered the services within modular networks, that is 2.3 in our from our syllabus, right. So the last point, that is we will see in our next lecture, right? So student, this is your test link. So you need to there are 3 to 4 questions and 3 minutes is the time. So the test is compulsory to all, so ma'am can send a link in a chat box, right? So all you need to appear for this particular test. And I have some of the students are giving the test multiple times by using some different nomenclature of their name, right? So you need to appear for only a single time. So first preference or first attempt only be considered, right? So you need to keep in mind that. Okay, so thank you for joining.